Next one, ascend. So ascend says that if you have an orderable b, right, which in most cases kind of means a number, but I mean it could be anything that's orderable. So if you have a function that, so I'm not entirely sure how to read that this in natural language, so apologies if I get this incorrect, but if you have a function from a to b, right, where b is orderable, oh sorry, I should start by reading this stuff. So let's start here. So ascend makes an ascending comparator function, comparator makes an ascending comparator function out of a function that returns a value that can be compared with less than and greater than. And let's just look at their example here. So they're saying they're constructing the comparator by age, and the way they do that is that they say R.ascend, which is the function in question here, but then they grab the property age from whatever is passed to it. And then they can pass this comparator to the sorting function. So this is why we would want to construct the comparator. This comparator we construct, and then we pass it to sort, and then that comparator is used. So I mean, if you think about it, I'm not entirely sure how sort works, or actually, I mean, let's just quickly glance into it, right? I mean, sort blah 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 blah. Return a negative number if the first value is smaller, a positive number if it's larger, and 0 if they're equal, right? So sort takes a comparator function that let's see, diffs two numbers, and so the way we can use ascend is to create one of these comparator functions that, when given two values, can compare them. So that's, if you look at it here, right? I mean, so by age becomes this comparator function. So let's see if we can try to figure out this now. So these are probably the two values, right? Yeah. So when given, right? So when given something of type A. So when given a function that given something of type A will produce something of type B, where B here is probably the thing that's comparable using these operators. And then when that's given an A and then an A, right? Which are these, so the first one and the second one. So in some sense, this is the comparator function that's produced. So yeah, actually it has to be like that, right? So this would be the first item, and this would be the second item, and then this is the number that's, as we read from the sort part, that's either less than, I can't remember what it was less than 1, or let's look at it. I mean, larger than a positive number, negative number, or 0, right? So that's what this comparator function does. So instead of having to write that on our own, we can just produce one of those for when we have scenarios where we already have numbers, for examples. But anyways, so let's say that we have a person 1 here, which has an a, or actually, yeah, which has an age which is 20. And then we have a person 2 here whose age is 40, and then we want to construct a comparator, right? So by age, so we're sort of following their example. Then we would say R.ascend, because we want to sort in ascending order, and we get the property age out. So that's our comparator. And now we can sort, but instead of using sort of this more complex scenario where we use the sorter, let's try to dig down into this part. So what happens if we say, if we say just by age, we should get a function, right? We get a function, okay. But if we apply it to P1, we should still get a function. Still a function. And if we apply it to P2, let me just use this syntax, we still, no, right, then we get a number. Sorry, of course, then we get a number. And what does this -1 say? Well, let's look at sort again. So negative number if the first value is smaller, and a positive number if it's larger. So negative number if the first value is smaller, right? Which makes sense. So 20 here is less than 40, which is the reason, let me clean that up. Which is the reason then why this returns a negative number, so it returns -1. And if we would switch these, if we would say P2, P1 in the other order, then we get 1, right? Because now we have the 40-year-old person at first, which is older than the second person. And if we would pass the same object twice, right? So they have the same age, then we get 0. So again, like, you could clearly construct these functions on your own. Like, many of these things you can trivially do on your own, but now you don't really have to think about it, because the point is, like, okay, you have a number, yeah, you have your number in your structure and you just want to compare by that number, so you can trivially construct a comparator function. And of course, one of the good things about this is of course then that you can do ascend here, or in other words, you can do ascend and descend. So I mean, let's add a third person here, and then let's say that this person is 60, and then we can say by age. So we want to do R.sort by age, and then we pass P1, P2, and P3. And actually, I think they're already sorted, so that's a bit silly, but yeah, it doesn't matter. So, and then we get the original objects. Important, right? We don't get the comparator now, because now we're sorting. So now we're actually digging into the sorting method, but we get them in ascending order. So 20, then 40, then 60. But this is the power of this. I mean, we could also say descending. Is it like that? Yeah, descending. And then we get them in the reverse order, right? So we can use the same function to extract the property here. We use the same property, but we pass them to a different comparator constructing function, and that can then be passed to sort in order to sort in different ways. So super convenient, And you can probably sort, I mean, let's try this out. I mean, if we would have strings here where this would be A and this would be B and this would be C, maybe age doesn't make any sense, so I'll go insane. I mean, let's just rename this to name, and then instead of age we have name and name here, and then let's run, right? So then we have CBA, which is actually descending, right? And if we do ascending, yeah, that works fine as well. So this probably has to do, let's jump into Node for a moment, and let's say, is A greater than B? That's false. Is B, is A less than B? That's true, right? So, I mean, there isn't really any magic going on here. It's just that these are strings, and strings are probably natively comparable using the less than and greater than operators in JavaScript. So, yeah, I mean, that's what we're doing here. We're delegating down to the actual comparators of JavaScript, but we are constructing our own comparator where we can decide whether it's ascending or descending. Super useful. Let's move on. Next one is association, or associate, I guess. ASSOC.